Among the icon menus, there is an icon rotating menu. This is a frequently used function that allows you to rotate the instrument panel needle or rotate the picture. Click on Icon Rotating and draw a location near the center point of the object you want to rotate. The center point will be in the upper left corner of the square. This icon will act as a rotating level needle on the left meter. For now, let's set the VP address to 50. To get the instrument needles we prepared in advance, we will open the 48 ICL file. In the 48 ICL file, click the plus button to bring up the instrument needle. The background color of the icon file must be black, and there must be black margins on the top, bottom, left, and right of the icon image, so it is transparent. Also, since the black part of the icon image is also transparent, black is not used in the icon image. When you select an icon, a screen will appear where you can select the center of rotation. Click to determine where the center of rotation will be. Later, you can fine-tune the rotation center property in the Properties window. The needle icon picture is diagonal, so of course the needle is pointing to the 0 position. If you set the needle to the 0 position, that is, the starting angle to 0, you only need to adjust the maximum angle. That is, if the range of movement is 90 degrees, the maximum angle value will be approximately 90 degrees times 2, and if it does not match the markings, you can adjust the ending angle little by little. You can fine-tune the icon rotating center value. It is more precise than the mouse, so you can do more detailed work. First, specify the range of important data. Set start value to 0 and end value to 9. Of course, you can specify the range of data as needed. Next, specify the angle range that the needle will move. Roughly speaking, it seems that it should move at an angle less than 90 degrees, so set the range to around 0 to 170. For reference, in DWIN, 720 degrees is the 360 degrees that we know. So, you have to double. Since the 0 position of the needle has already been drawn, let's set the initial value to the maximum value 9 and preview it to check the angle when it is at the maximum value. Even though I roughly guessed at it, it came out similar. If necessary, you can adjust the maximum angle a little bit to get it right. The rest of the data values will be adjusted automatically, so you only need to adjust the start position and end angle. Once the left dashboard is complete, you can copy this widget, place it on the right dashboard, and just change the VP address to 5100. The rest is the same, so there's nothing to change. Both look the same. Later, if you send data to the left instrument panel VP50 and the right instrument panel VP51 or 0 respectively, different stereo levels will work. In the previous chapter, we used artistic variables and expressed numbers and pictures in 10 pictures. To review, let's use that function to add a digital level meter. Since it is a vertical type meter, it is a picture, so draw the range to be erected. The VP address will move like the left instrument panel, so make it the same as VP5000. Select the icon ICL file that contains 10 pre-made icon images, numbered 0 to 9. As you can see, there are 10 pictures of the same size but with different level indicators. Leave the rest as is, and for preview purposes, specify default data values. Enter the maximum value in preview to check if the size is correct. Make sure it is level with the left instrument panel. Once one is completed, you should have one more level meter like the right dashboard, so copy and paste the widget you created, and change only the VP address to 5100. It's the same VP address as the right instrument panel. Here, for reference, when setting the default value, as in here, when using 2 or more of the same VP addresses, the default value must be set to the last widget. Even if the default value is changed in a previously created widget, it will be ignored. If you preview it, it is normal if the levels on the instrument panel and the digital level meter appear together. This time, let's try rotating the volume dial. Again, we use the icon rotate widget feature. The volume will rotate around the exact center point, so position it at the center of the volume. Since it will move regardless of the dashboard, change the VP address to 5200. Then, from the icon file, select the volume shape and select the rotation center point as the exact center of the volume. The volume icon is convenient when cut from the original background image, as it will have the same shape and size. However, if you rotate the disk, it will look awkward even if it is not an exact circle or the center point is slightly off, so it is a task that requires meticulous care. The data change range is from 0 to 9, and the angle range is roughly around 250 degrees, so the maximum angle is doubled to around 500. When I ran the preview, the angle was much larger than what I saw with my eyes. By adjusting the maximum angle several times, we find a point that matches the starting value and modify it. This time, we will work on making the volume return to touch using the slide. It sends and returns data, but by touching the blind and turning the volume, you can send the current volume value to an external device. When sending data, a slide icon widget is used, whose position changes depending on the value. Draws the range of slides to move horizontally. Since the VP address must move together with the volume, change it to 5200, which is the same as the volume address. The data range is set to 0 to 9, the same as the volume. The direction in which the slide moves is set to horizontal, and an icon to be displayed as a slide is loaded. Among the icons, select the one that looks like a slide volume, set the default value to 5, which is the middle value, and preview it. You can see the slide icon appearing in the location. This will allow us to send data and change the slide position, but let's add the ability to move the slide by touch, rotate the volume, and send the current slide value to an external device. If the icon slide displays the icon position with the received data, the slide touch function changes the value of a specific VP address when the hand moves left and right within a given screen range, and simultaneously sends the current value in real time to an external device. Create a rubbing range with your hand. Of course, it will be a range that covers the icon slide part. When rubbed with your hand, the location will match the location of your hand. Specify the VP 5200 address, such as the icon slide, and the range of values to change is made as 0 for the start and 9 for the end, like the icon slide. For all touch widgets, you can choose whether to send touch-related values when touched. If you check the Data Auto-Uploading box, the touched VP address and the current value of the widget will be sent when touched. Open the preview window, and instead of actually touching, try rubbing the touch slider with your mouse. You will see that the icon slider moves as you rub it. Of course, you will also see the volume with the same VP address rotating. Now that it's complete, let's see it in action. Let's create 3 more lists for DWIN. The first one is for the left meter VP 5000, and the data range is 0 to 9. The second one is for the right meter VP 5100, and the data range is also 0 to 9. The last one is for the slide and volume VP 5200, and the data range is also 0 to 9. Let's try to make it work with the newly created list. I'll set the repetition speed to 500 milliseconds and run it. The actual screen you see will be rotated at about 10 times the speed. The computer preview screen has a slow processing speed, so if you rotate it faster than this for a long time, the program may stop, so this speed seems to be the limit. This time, let's look at how data is transmitted to a smartphone when you touch the slider with your hand. Go to the Serial Work screen, where there is a data receiving window, and check the hexadecimal mode. First, let's lightly touch the slider part. On the right, you can see that data is being received. There are several data, but it indicates that it came from the 5200 VP address, and the last 2 bytes show the current value status. It means the value is 0004. This time, let's rub it continuously. You can see that data values are received continuously. You can receive this data and use it for various tasks, such as varying the speed of a motor or the brightness of a light bulb in Arduino, etc.
Goodbye. See you again. Like and subscribe, please.